You have the cover slide, mass timber construction per the 2021 IBC, background and overview on your screen. As Lori indicated, my name is Matt Hunter. I'm the Northeast Regional Manager for the American Wood Council and have been with them since June of 2015. So happy to be here sharing this virtual webinar with you today. And I hope you're having a good afternoon or good morning, depending where you are in the country. Since we are recording this webinar, we're just going to go through these other slides that Lori had commented on previously about the disclaimer that we are recording. And of course, there is ICC and AIA credit being offered for this particular presentation. This program is copyrighted. Some of this material is actually included in the document that you see in your lower left-hand portion of your screen, the Mass Timber Buildings in the IBC, that was jointly published by the American Wood Council and ICC. So lots of great information in there. If there's something in the presentation you see or would like to use, just please give us an email, reach out to us, and we'll get you a copyright request form, and we can go from there. All right, so without further ado, basically this particular program is about the tall mass timber code provisions that are part of the 2021 International Building Code, which from our friends at ICC, we are on bated breath to receive, but the word on the street is that we should be getting the 2021 I code sometime in October. So kind of middle of the road October already, so hopefully it comes soon, hopefully before Halloween. But basically this program is going to introduce you to the Tall Wood Building Ad Hoc Committee that the ICC formed, how it was created, what was the impetus behind the formation of the Tall Wood Building Ad Hoc Committee, and the research and the stakeholder-driven process and consensus-based process that was a result of the Tall Wood Building Ad Hoc Committee. We're also going to go into depth about the research in fire resistance testing that was done and carried out at the ATF lab, and look at some of the technically substantiated code changes that were done in the 2018 Group A code development process. So the 2021 IBC generates 3 new types of construction that allow us to go much higher than the currently code-approved Type 4 heavy timber construction heights of 6 stories and 85 feet. So we'll kind of go into depth on those issues a little bit later on in the presentation. But what do we want to talk to you about today? We're going to introduce you to the makeup of the Tall Wood Building Ad Hoc Committee, go over the process that was used to reach consensus on the proposed code changes, and basically want you to learn how the new types of construction compare with the existing types of construction underneath the IBC, and the different and conservative approaches that are used for the new types of construction, Type 4A, B, and C. And then last but not least, we're going to look at the required fire resistance components for tall mass timber buildings under the 2021 IBC. So as Lori indicated, you're in Module 3, so some of this information, some of the general information has been covered in previous webinars. And we'll have the dates for the follow-on modules for you, so hopefully you can tune in and attend those as well. But you're currently at Module 3 in a 6-part series. So our first polling question, it's not timed and it's not really graded. We just, for our records, we'd like to know what's your profession. Are you a design professional? Are you a building inspector, code official, member of the fire service? Or are you a builder, contractor, manufacturer, or other? Please vote now.
All right, we've got about 80% of our attendees that have responded, so let's go ahead and close it and share the results. We have 8% architects, 63% engineers, 21% code official, 3% fire service, and 5% in builder, manufacturer, or other. So welcome, everyone.
Absolutely. So glad you're here today. So let's keep right on rolling. So before we start off, we just want to kind of emphasize and hammer home the point that mass timber construction, or specifically tall mass timber construction, couldn't be farther away from conventional light frame or conventional stick-built construction. The photo on the right you have is a typical podium or pedestal construction under Section 510 of the IBC. So you have a 3-hour fire resistance rated separation, typically a non-combustible separation, parking area, something like that underneath. And then you have conventional stick-built or stick frame construction above. 4/1 is a really common configuration on this type of construction, typically type 5, but it could be light gauge steel and type 5 construction as well. But in this case, we're looking at repetitive wood light frame. Compare and contrast that with the image to the left of your screen there. That is the Brock Commons project. That's a university student housing. I believe there's some mixed use on the first floor, some stores, stuff like that for the kids, for the college kids. With 2 reinforced concrete stairwell and hoistways. They have some seismic issues at University of British Columbia on the coast there. So those 2 reinforced concrete hoistways and stairwells help stabilize the structure as well. But it's a 3-hour non-combustible concrete first floor and a total of 18 stories of glulam and cross-laminated timber ceilings and floors associated with that project. It's one of the tallest tall wood buildings in the world. I think there's one in Austria that's taller, and we even have a very tall one coming to Milwaukee, the Ascent building. But that just gives you an idea, a visual concept of what's the difference between conventional light frame type 3 and 5 and the new type 4 methods of construction, pardon me. So we talk about types 4A, 4B, and 4C in the 2021. And we also want to clarify the distinction between those new types of construction that are clarified in the code, as well as the designation of HT associated with the traditional type 4 classification. So historically, type 4 buildings have been masonry exterior walls, typically 2-hour rated, with all other structural components inside the bearing walls being of heavy timber dimensions. So the code is very specific on the heavy timber dimensions associated with these types of columns, beams, and floors and roof assemblies. They have to meet minimum nominal thicknesses to be considered a heavy timber classification. The picture on your left is taken from the Butler Building in downtown Minneapolis. It's a 9-story type 4 building, has masonry exterior walls. The columns at the base, you can't quite see the very bottom of them, are 24 inches by 24 inches. And the columns at the uppermost story are 9 inches by 9 inches. You can see the decking and the floors there. The columns and the beams are very robust, of large size. You can even see the roof decking as well. So fully sprinklered, and it's kind of the linchpin of the downtown revitalization of Minneapolis. But this is exceeds the current type 4 heavy timber limits in the IBC at 9 stories. But again, traditional type 4 heavy timber building on the left, and the new type of mass timber buildings on the right. We already talked about the outline. We'll jump right into the ICC Tall Wood Ad Hoc Committee. So way back in December of 2015, there was a letter sent by industry and I think the Wood Council as well to possibly look at the newly developed science overseas of tall wood buildings and whether or not this would be feasible to incorporate into the building codes and what would be required on taking this action to develop code changes and standards within the I series of codes. So that was sent to the ICC in late December. By early January, they had determined that a tall wood building ad hoc committee was needed and it was warranted. They sent out requests to serve on the committee. I think they had over 80 submissions to volunteer for the committee. So just like everything else I see, it was a consensus-based process comprised of building and fire officials, design professionals like architects and engineers, notable fire protection experts, representative from the various building construction material industries, concrete, steel, and wood as well, and other construction-related professionals, all made up membership of the ICC Tallwood Building Ad Hoc Committee. So based upon the size and the scope of the ask that would be required to get tall mass timber buildings into the building code, the ad hoc committee broke their membership into 4 work groups. They were comprised of definitions and standards, fire, structural, and codes. Right off the bat, they indicated 82 major issues that had to be resolved by the members of the committee. They reviewed hundreds, if not thousands, of pages of reports and documents. They had face-to-face meetings, remember those, before COVID-19, and they had many logged-in teleconferences to discuss these issues that were identified by the work groups. When they identified those issues, they came up with some agreed-upon performance objectives, and we'll delve into that next. So the Tallwood Building Ad Hoc Committee determined that these performance objectives needed to happen for these code changes to move forward. No collapse under reasonable scenarios of complete burnout of fuel without automatic sprinkler protection being factored into the performance of the building. They wanted to ensure that there was no unusually high radiation exposure from the tall mass timber building in question to potentially causing a threat or hazard to any other adjoining building or property. Correspondingly, they wanted to ensure that an adjacent fire in a building or structure or property next door to a tall mass timber building wouldn't negatively affect or compromise the tall mass timber structure. They had specific concerns that were raised by the fire service. They wanted to ensure, just like high-rise buildings across the United States, that there were no unusual fire department access issues. The egress and escape systems should be designed to protect the building occupants during the design and escape time, plus a reasonable factor of safety. And they wanted to ensure that the fire suppression or sprinkler systems that were mandated in part with the code changes reduce the risk of failure during reasonably expected fire scenarios. So in other words, equivalent risk to equivalent performance. They want to make sure that the height of the buildings are appropriate for the evacuation time and the threat of collapse for the proposed types of construction. The Tallwood Building Ad Hoc Committee determined that its comprehensive package of code changes met all the performance objectives that were identified. And the picture here is the test structure at the ATF lab, which we're going to delve into when we get to the fire tests. So a very active work group was the fire work group. They determined that the fire tests be performed or undertaken to validate the proposed code language changes that the Tallwood Building Ad Hoc Committee put forth. So they determined that the test structure be a 2-story configuration. 30-foot by 30-foot column line is fairly commonplace in the design profession. So they went with a 30-foot by 30-foot interior dimensions. They wanted to ensure that corridors and a stairwell were included in the test configuration with the structure. And they used the Underwriter Laboratories Modern Furnishings fuel load. It was, I believe the design fuel load was approximately 550 megajoules per square meter, but the as tested conditions were slightly higher at 570 megajoules per square meter. So the fuel load was determined by a survey of group residential occupancies, and they determined that the fuel load was approximately in the 85th percentile of all those occupancies that were evaluated under the residential occupancy. So multifaceted purpose for the tests. They wanted the test to be realistic to evaluate the safety of both occupants and firefighter during egress and suppression efforts, and also to capture as much data as possible to support further development of relevant codes and standards provisions. So at the ATF lab, there were over 600 data points that were installed and collected within the structure during all the tests. And as we discussed ever so briefly, the test compartment and the test were run at the ATF lab in Maryland. and the test was supervised by U.S. Forest Products Laboratory staff. So again, there's that slide. We talked about the dimensions, and we have a couple schematics and plan views to kind of show you what that looks like before you see the test videos. So 30 foot by 30 foot space with a 5 foot wide quarter. So the CLT panel we're looking at right now is approximately 36 feet long. And I'd say just from looking at the guys on the ground that it's about 12 feet wide. Maybe a little bit north of 12 feet wide. Just like a tilt-up or a stand-up panel, these lifting points are installed from the factory. If you haven't been privy to all the previous discussions on CLT, CLT is cross-laminated timber, and it's like plywood on steroids with nominal solid sawn boards cross-layered in odd number of increments, 3, 5, 7, etc. We'll get into some more details about the configuration of the panels and also the test procedures for each test that was conducted at ATF. So there's the plan view schematic of the actual compartment that was tested. You can see the quarter there, the stairwell. There's a 20-minute door at the compartment into the unit, and there's a 90-minute door at the end of the hallway going toward the stairwell. So tests 1 through 3 in both the upstairs and downstairs compartments were to simulate the unlikely scenario that the fire suppression system fail and the fire service is unable to respond or unable to charge the standpipe. Test number 4 is a normal activation of one sprinkler head at a point source fire, in this case the kitchen. We'll talk a little bit about the location and the testing configuration there as well. And test number 5 was to simulate a failure of the sprinkler system to activate and having to be manually charged by the fire service through the standpipe or riser. So we'll take a look at that now. So tests 1 through 5. Test 1 is our baseline test. So we have 2 layers of 5/8 type X gypsum wallboard over all exposed mass, or all not exposed, all mass timber surfaces. That ran for 3 hours. Test number 2 was 30% of the CLT ceiling area in the living room and bedroom were exposed, and these represent maximum exposure that would be permitted under the new type 4 building type. Test number 3, test number 2 ran for 4 hours as well. Test number 3 is 2 opposing CLT walls, and we'll show you in the schematic where those walls were, one in the bedroom, one in the living room, again to simulate actual field conditions to be installed in type 4B construction. Type 4. Test number 4 is all mass timber surfaces fully stripped of protective gypsum wallboard at a normal activation of the sprinkler system. And you can see the corresponding time there. And test number 5 is, again, all mass timber surfaces exposed and a planned 20-minute delay that they stretched out to 23 minutes before a simulated charging of the sprinkler standpipe. And you can see the corresponding time duration there. So poll question number 2, a total of how many fire test scenarios were conducted at the ATF lab? Should be launching the poll now.
All right, it looks like people were paying attention. All right, and we're coming up on 30 seconds, so we'll go ahead and close it and share the
hopefully
results.
our audience were paying attention, and
58% said choice C, 5, and we had 28% that said choice B, 4, and 9% said choice D, and 5% said choice A. So the majority of folks said choice C.
Yeah, 5 tests were conducted at the ATF again, and we'll talk a little bit about each test a little bit later on in the presentation. So here is our configuration. You can see in the isometric there, the stuff highlighted in yellow is a glulam beam and column assembly with steel stud non-combustible infill with 1/2-inch gypsum on both sides of that demising wall. Again, we're doing a 30-foot by 30-foot apartment, 9-foot ceilings if it matters. 5-ply CLT, again, CLT is always assembled in odd number of laminations, 3, 5, 7, 9, etc. This particular wood species was from the Douglas fir large group, and the lamination thickness was 1.375 inches, which, if I remember my carpenter framing days, is 3/8, so about 1 inch and 3/8. And the CLT panel thickness for a 5-ply panel is just under 7 inches, or 6 7/8. For those of you that may have witnessed some other CLT testing, this is a polyurethane adhesive, and it had a cross-linked additive in it to ensure that the bonds of the individual laminations were indeed fire resistant. Some of you may be privy to the initial tests that were conducted at NIST, where we had an unexpected post-secondary flashover condition, and we'll talk a little bit more about what that means. It's not like a raging inferno like you saw with the movie Backdraft or anything, but it's a flashover is 600 degrees, a temperature of 600 degrees Celsius, measured 1 foot from the ceiling. So while all the components in the room might not be spontaneously combusting at that temperature, the technical definition is whenever 600 degrees Celsius is obtained is measured at the top of the ceiling, you have the technical definition of a flashover. Flashover, yes, correct. So the apartment layout, we already talked about the demising wall with 1/2-inch gypsum in between the living room and bedroom space. Each compartment is roughly 15 by 30. We talked about the 20-minute compartment door and the 90-minute rated door at the end of the corridor leading to the stairwell. And we talked about the fuel load. We'll talk about this 23 megawatts a little bit later in the presentation when we do a breakdown of the individual tests. But the long and short of it was the first test that where all the gypsum was covering the exposed mass timber elements was 18 megawatts, and the tests 2 and 3, which had some exposed mass timber elements, went up to 23 megawatts. So here is the typical configuration that was used throughout all 5 tests. It's about $5,000 worth of IKEA furniture up in flames. You can see in numerous locations, there's piled wood furring strips or blocking and cribbing used to increase the fuel load. They installed OSB sheathing on the floor to increase the fuel load as well. You can just see the cribbing is basically stacked everywhere. We have books on the shelf, the plastic coverings are still left on the mattresses, and you'll see those start to off-gas and pyrolyze during the fire tests. Just some additional still photographs of the testing compartment space. We'll talk about the fact that you can't use combustible framing other than mass timber or heavy timber elements associated with the new 3 new types of construction, but you can use non-combustible. So you see the steel stud assembly there being used for the plenum on the left, and then the finished detail on the bottom left shows you where the ductwork would be. So no exposed CLT in the plenums. They're going to be covered up with gypsum. It's backled and taped as well. The top center photo is our microwave, range location where the test is going to be initiated each time. And you see in the upper right is the exposed ceiling configuration that would have been present for test 3. And you kind of see them in the lower left as well. And the bottom right, you see the living room kitchen configuration where the ceiling is exposed. Just more detail photos, more furniture, more combustible materials. And the bottom center photo there for you. And in the interest of time, we're going to show the ATF test number 2, which is the exposed ceiling configuration test. But all these videos, I would highly encourage you to watch. They're just fascinating videos to watch. The intensity of the fire is pretty breathtaking. If you have not witnessed any fire testing before, it's personally the largest most severe fire test I've ever seen. I thought 6 or 8 megawatts was a large fire. 18 and 23 megawatts are just massive fires. So again, test number 1 is fully protected. Test number 2 is the exposed ceiling. Test number 3 is the exposed walls. Test number 4 is normal activation of 1 sprinkler head. And test number 5 is a forced delay of charging the standpipe to activate the entire sprinkler system in the test compartment. So what I'm going to do for you is some more photos, or just some more still photos here. Some of you that may be paying very close attention might be wondering what these tripods are. These tripods were deluged nozzles that were installed at the request of ATF. They were very concerned about the scope and the size of this test. It was one of the largest and hottest tests that was ever performed at the ATF lab. So they were very concerned. So they hard piped these deluge nodules inside the compartment so they wouldn't have to send firefighters into the compartment. They were also concerned about the plenum ductwork on the exhaust hood that was pulling all the particulate and smoke out of the testing facility and then running it through a filter because some of the flexible duct was sheet metal, and they were concerned that the exhaust gases might be so hot that it might damage the ductwork. They had a firefighter in full turnout gear, a Scott air pack, and a hose up in the ceiling assembly, ready to wet down that ductwork plenum in case it got too hot. Fortunately, none of these extra safety measures were needed. And although it's not visible in the photos, there are large deluge like deck guns for water, spraying water all over this test assembly floor in case the fire does get out of hand. So the pretty robust firefighting capabilities at the ATF lab. So I believe that's going to lead us right into our video. Here's some more still photos. Again, a confined source of origin. As a fire starts in one place, in this case, the lower kitchen cabinets. The kitchen cabinets, the fuel load of the kitchen cabinets themselves are enough to cause the flashover in the living room kitchen space. The flashover in the living room kitchen space through the open door of the bedroom is hot enough and severe enough to cause flashover in the adjoining bedroom space. Then we move into the decay phase, and there's just some still photos of the documentation to document how the structure looked after the first control test with 2 layers of non-combustible gypsum on all mass timber surfaces. So I'm going to run ATF test number 2 for you. So Lori, if you can please let me know if the video is up on the screen.
Looks good.
Okay, so you should hopefully see firefighters walking around in turnout gear. So throughout each test, the fire service is going to come in with a propane torch on a extension, almost like a piece of pipe, and they're going to ignite a gasoline-soaked rag in the range, the kitchen oven range space. And this is a time-lapse video, so it'll speed up, but I'm just going to let it run through and play and provide you some commentary on the way. And we have all this data recorded in a tabular format, and also the final report has been issued by the Forest Service, so you can check out that report at your convenience. You can see the kitchen cabinets are enough to have the flame licking on the top surface of the great room there. And again, ADBC is really pretty much an advocate, as should all design professionals and building officials and building inspectors, about fire safety, construction fire safety. I believe UL has a program, Shut It Before You Sleep. You'll just notice the heavy black smoke and flame coming in through the bedroom door. So if you're in the habit of sleeping with your bedroom door open at night, please, for your own safety, shut the door. It just makes all the difference in the world, giving you more time to escape. So we have flash over there. You can see that the chairs were the last thing to spontaneously ignite. But again, remembering our criteria for flashover, well before that happened, it was over 600 degrees Celsius, 1 foot from the ceiling. So you can see the black smoke and the open, actual just flame front rolling on the ceiling of the bedroom compartment, and the off-gassing occurring with the plastic covering on the mattresses we're about to go to flash over here as well. It'll just spontaneously ignite. The lower right square and the Hollywood squares that we have here on the screen is an infrared camera view of both compartments. You can see we're fully developed now, and the fire is continuing to build in the adjoining bedroom space. The little square where you see the little flame front on top is a little flame front penetration through the 20-minute compartment door. You can see the embers and the glow below the door there. Light gray wispy smoke in the corner, and the image to your lower left is the 90-minute fire-rated door into the stairwell. So you can see some charring and some flame front through the door. It's tipped open a little bit. But this door was really like the little engine that could have held in there for quite a while. I believe it was 63 minutes for this. So close to 60 minutes, 57 minutes, I think, for the first test. And I think right at 63 minutes for test number 2 here, you'll see it fall into the compartment, couple embers out in the hallway. But we're clearly in the decay phase, and they'll let this run. They'll speed this up, but they let this run out to 4 hours. So it did so. The CLT did self-extinguish, and the fire was almost out at the 4-hour point. So, and that was for ATF test 2, where the ceiling was exposed. So they made sure the ceiling CLT panels on the ceilings were adequately loaded. They were using water barrels to simulate that load. Again, just a couple more still photos, the amount of cribbing and combustible material, room and contents, as they say in the fire service, that was in the unit. So we already did test number 2 for your viewing pleasure. And again, you can find all those videos on the AWC YouTube channel. If you can't find them on the AWC YouTube channel, just go to YouTube and search ATF CLT fire test, and it should pop up for you under YouTube. You can just see the size of the flames. I attended test number 3, which was the exposed walls in the bedroom and kitchen and living room space. And I was frankly concerned that it was going to get out of hand. During test number 1, which was the control test with a little less heat release rate of 18 megawatts, the tempered glass in the observation control room shattered. It broke, it cracked, just went off like a gunshot. Lori can perhaps chime in on that, but there were lots of startled professionals, industry professionals, that were kind of taken aback by that. And the control room is probably 5 to 6 feet above, maybe 10 feet above the second floor elevation, and probably maybe 50 or 60 feet away. So you can see just by the size of the flame in the pictures, it's just massive fires. You could feel the heat radiating through the glass. It was that hot. It was the hottest fire I've personally witnessed. So for test number 2, where we charred the exposed CLT on the ceiling, you can see the pictures before demolition occurred. And here's the crew going through demolition. You can see our glulam beams and columns are relatively unscathed. I think we have some pyrolysis there on the edges, not actual active flame front penetration or charring, just starting to off gas and drive off some of that inherent moisture in the wood. So we'll get into a little bit later detail about how critical it is for the drywall detailing and fastener schedules, but that's a key component of this. So we had the fire growth, we had fire development, fire decay, and it basically went out, and the mass timber self-extinguished. There was no water applied to the exposed mass timber surfaces on the ceiling in ATF test 2. So here's an obtuse angle still photograph of a piece of CLT taken from the ceiling. And here is a 90-degree right-hand view, so to speak, of the 5-ply CLT panel. Again, we referenced the production standard. If you're looking at CLT for mass timber buildings under 2021, you want to make sure you're looking at ANSI APA PRG 320, which mandates, some full-scale tests without protection, with protection, and also mandates the use of fire-resistant adhesives to make sure there's no char fall off potential delamination from one layer to the next. That's a key issue. But wood, per the TR10 that's referenced in the National Design Specifications that IBC publish, typically wood chars, softwood lumber, most wood chars at 1.5 inches per hour, give or take. So we're not quite through 1 3/8 inches here on the bottom lamination, but this heated zone would have been very hot, just right above that char line. So the adhesive did its job. It held together, performed well during the tests. So again, test 3 was exposed CLT walls. The schematic shows where the CLT walls were left bare during test number 3. Photos very similar in scope and size to the previous test. And again, we did highly encourage you to take your time and to go look at these videos at your leisure so you can gauge for yourself just how severe the fire was. Contrary to popular belief, these slide stills here, these photo stills are not from test 4. Test 4 is a normal activation of the sprinkler. And if we get a chance, we'll let that one spool toward the end of the program. Nothing really to write home about. The charging the standpipe in sprinkler test or in fire test number 5 is much more an impressive test. So for our friends in the fire service, they've told me on numerous occasions, whenever you have light gray or white wispy smoke, it means the fire is just about out or not really developed yet. So you can see the light gray smoke in the bedroom here, some strobes going off, and you can see that we haven't really even involved the upper kitchen cabinets with this point source fire. So the one sprinkler head did its job. We all know that sprinklers protect lives, and if it's a full 13 NFPA 13 systems, we're protecting both lives and property. And NFPA 13 sprinkler systems are mandated as part of the tall mass timber changes. So ATF test number 5 was normal activation of the sprinkler system. So we went to the first floor, and instead of having both compartments open, they glassed them in to simulate, a sunroom, a slider, a patio door, French door. And if you look at the test video, you'll see the fire service come by mid-test and start breaking glass to try to encourage more oxygen into the envelope there to promote more flashover conditions in the second compartment. But you can see the flames rolling out of the top of the top of the glass. The fenestration there's all broken out, so the flame was burning there. And again, they extended that test for about 3 minutes, and they charged the standpipe at 23 minutes. So here is an event log. It just kind of summarizes what occurred at the ATF lab. The flashover time has varied a little bit for the first compartment in the living room and kitchen, probably within give or take a minute of each other, up or down. But notice how uniform and how repeatable flashover occurred in the bedroom. Again, that open door really facilitated the heat and smoke and flame going into the other side of the unit. And flashover occurred within 20 seconds over all 3 tests. So as we showed you in the video, we had some flame front penetration of the 20-minute compartment door in the hallway. We went almost 27 minutes before we had flames in test number 1, a little bit longer at 30 minutes, give or take, in test number 2. We had a little hiccup on test number 3 where the door frame installation went awry. So we didn't get as much fire resistance out of that 20-minute rated door as we would have liked. As you saw in the video for test number 2, the compartment door held out for almost 64 minutes, very close to an hour for test number 1, and again, an accelerated failure rate at just about 30 minutes for test number 3. We didn't have any compartment door failure issues with tests 4 and 5 because they didn't go along that far. Sprinkler activation at 2 minutes and 37 seconds extinguished the fire, as well as charging the standpipe test number 5. The fire was out at 23 minutes, or started to go out at 23 minutes. It took a couple minutes for the sprinkler system to bring the fire under control. Some timeline there, we talked about that, flashover times, right at 17 minutes for the bedroom. And we talked about the breaches of the compartment door and the installation error on test 3 for the 20-minute door. no compromise and no failures with the 90-minute ready door at the corridor associated with the stairwell at the end of the hall. So some modeling research that was conducted by the Research Institute of Sweden, or RISE, estimated with their modeling that the heat release rate data should be approximately 20 megawatts. It ended up being a little bit more robust than that, but you can see with the black line is the projection matched really pretty closely with the data that was recorded at the ATF. Correspondingly, if we look at the ceiling gas temperature, again, with some spikes and ups and downs, and a little bit more than they anticipated, which is good for making sure your testing is robust, but fairly steep rise, a plateau, and then a decline. So there's a little bump there in the actual data, but it's just a downward trend is what we're looking for. And of course, no post-secondary flashover. So when we start talking about these values and these figures, I'll go back to this previous slide here. Heat release rate. So the megajoules per square meter anticipated design value was 550 megajoules per square meter, slightly hotter at 570 megajoules per square meter. The engineers, the fire protection engineers, tell me that a 500 kilowatt campfire is something you physically cannot stand next to. You have to back away from a 500 kilowatt campfire. I had seen, I think, 6 or 8 megawatt fires in testing before. I thought those were fantastic fires, just, you know, severe fires. Literally, this testing just blew me away how severe it was. The engineers tell me that 23 megawatts is the energy equivalent of 360 gallons of gasoline. So you can imagine the amount of damage and the energy released by consuming 360 gallons of gasoline. So a 23 megawatt fire is just a rip-roaring fire, a very severe fire, and the ATF, of course, took it very seriously with their additional safeguards we talked about previously. So each of the test configurations that were done in support of the tallwood ad hoc changes basically were validating code change proposals in the 2021 IBC. So we know that the fire test plan was developed by the fire work group. The test plan as tested at ATF had various generic connections that were recommended to be tested by the structural work group as well. And we had that demising wall with glulam beams and glulam columns in addition to the CLT being tested, the 600 data points. So all this data was harnessed and gathered up for use in future testing. So very, very useful. Complete copy of the report took us a while to get, but it's here. It's available as a link on our website. You can go to awc.org and click on tall mass timber. It'll take you right to a page where you can click on this and download this document. But again, it was supervised by U.S. Forest Products laboratory staff, and it was conducted at the ATF lab in Maryland. Okay, we're going to talk a little bit about the consensus process, how we got to where we are in the 2021 IBC. Again, we had a total of 17 changes. 14 of those were in Group A. That resulted in 3 new types of construction, Type 4A, Type 4B, and Type 4C. Associated with those new types of construction, we have entries for maximum overall height, maximum number of stories, and square footages per floor, per the table tabular values in the IBC. There are a slew of new requirements for fire safety during construction, and they determined that an existing exterior wall test standard is still applicable, even though that NFPA 285 testing standard is one that's used for non-combustible walls. They figured that the stringency of that test would be well suited to be applied to the combustible form of construction, albeit with fire resistance and non-combustible gypsum and the inherent fire resistance of mass timber. It'd still be prudent to make sure those assemblies are tested in accordance with NFPA 285. So all 14 of the Group A changes and all 3 of the Group B changes were approved. for a total of 17 changes permitting tall mass timber to be included as part of 2021 IBC. So on this slide, we're showing the proposal numbers during the code development process, again, during the 2018 Group A changes for the 2021, and the numbers in parentheses are the actual code change sections as listed in the 2021 IBC. And again, the illustration in the bottom left corner of your screen is a joint document that was published by AWC and ICC detailing all these changes. And there's even an appendix in the back with some sample test questions. If you're interested, you could sit for exam number 93, which is a special inspector for mass timber through the ICC certification process. So lots of changes in the IBC and some of the construction, fire safety, and job site safety and training requirements in the IFC as well. So we have two new definitions for terms in the IBC. We want to define what mass timber is, structural elements of type 4 construction, primarily of solid built-up, panelized, or engineered wood products that meet minimum cross-sectional dimensions of type 4 construction. So just like heavy timber, they have to be of a certain size. They can't be stick frame. They can't be repetitive light frame wood. It's non-combustible or heavy timber dimensions. And we also have a definition specifically for non-combustible construction associated with mass timber, non-combustible material in accordance with section 703.5, designed to increase the fire resistance rating and delay the combustion of mass timber. So we're using those sacrificial components and typically gypsum products to exhaust themselves in the defense of the underlying mass timber. And that was a driving force on the Tallwood Building Ad Hoc Committee. Do no harm to the existing heavy timber provisions, and also ensure that 2/3 of the required fire resistance protection comes from non-combustible protection, while the remaining 1/3 comes from the inherent fire resistance of the cross-limited timber or mass timber assemblies. So here's just a brief table summary of the different types of construction, comparing the two. Again, we're not going to get too much into the stories, heights, and areas because those are covered in other presentations. But just remember that type 4A is the tallest, up to 270 feet and 18 stories. Type 4B is up to 12 stories, 180 feet in height. And type 4C is 85 feet or 9 stories. So the table here is telling you exactly what your fire resistant materials need to be for your structural building elements, non-load bearing walls, non-load bearing interior walls, and your requirements for shaft and exit enclosures. In the IBC currently, super high-rise provisions begin at 420 feet. With the tall mass timber provisions, they begin at 12 stories or 180 feet. We're just going to go through this and look at these examples. Okay, construction types, and here we have them listed because we may or may not have a quiz question on some of these topics. So again, we have 2/3 of the required fire resistant rating required to be non-combustible protection for types 4A and 4B. We can go much taller, up to 270 feet with type 4A construction and 18 stories. Little less overall height for type 4B, 12 stories up to 180 feet high. And we have provisions for limited exposure of mass timber elements within a type 4B building. And we also have some criteria and thresholds for how close those exposed combustible mass timber elements can be. Type 4C is, I think, going to be popular with the architects and the design community because it's going to be no requirements for non-combustible gypsum protection of the exposed mass timber or CLT or NLT or anything else. Certain features, plenum, stuff like that, hoistways have to be protected inside and out with at least one layer of 5/8 apex, but you can go a little bit higher than the existing 6 stories currently permitted in the IBC, but unfortunately we're still capped out at a conservative 85 feet. So maybe there'll be a future code change a couple cycles down the road, but at this point, fully exposed mass timber is maximum 9 stories and 85 feet, still with a 2-hour fire resistance rating. Probably should have clipped through these as we went along, but nonetheless. So here is the revised table 601 in the IBC for fire resistance ratings. You can see it's by no accident that type 4A lines up very well with a non-combustible unlimited type 1A building. So we have identical fire resistance ratings for the primary structural frame, bearing walls, and floor construction and roof construction for type 1A as we do for type 4A. Correspondingly, if we move over in the table to type 4B, we have 2 hours in the primary structural frame, 2 hours on the bearing wall, 2 hours on the floor, and 1 hour on the roof, just like we do for type 1B, a non-combustible building. When we slide over to type 4C, even though we're fully exposed mass timber building elements, we still have to basically double the existing 1 hour HT criteria for 2 hours for type 4C. So even though we're fully exposed, we still have to have that inherent fire resistance with a thicker section of our mass timber elements in a type 4C building. And it's worthwhile to note that we're not really covering on this topic all the types of construction type 4A, B, and C are required to be protected by NFPA 13 sprinkler systems. So all concealed spaces, closets, bathrooms, dwelling spaces, hallways, dead-end hallways are going to be mandated to be protected by NFPA 13 type sprinkler systems. So we already mentioned some of the fire resistant details. We're going to start looking at the fire resistant details for the exterior of the buildings as well. But as you can see from table 705.5 in the IBC, we're grouping type 4A and type 4B with applicable occupancy groups and fire resistance for some of the other non-combustible unlimited style buildings. So if you get beyond 30 feet, you don't have any requirements. You start to get closer than 30 feet, within between 30 feet and 10 feet, you have the same threshold for type 4A and B buildings as you do for type 1A and 1B buildings. And when you get even closer, you still have to meet the stringent criteria for the more hazardous occupancy groups in terms of the established fire resistance of the building elements. So 3 new types of construction. When we reference types 4A, B, and C, we're talking about the new mass timber types of construction in the 2021 IBC. The ad hoc committee was specific that we do no harm and not modify anything with the existing heavy timber provisions, basically only to rename them type 4-HT to clarify that they're different from the new types of construction. And indicate in the heavy timber sections where building elements are permitted to be heavy timbers. There's certain existing provisions in the IBC that allow you some limited application and limited use of heavy timber dimensioned members in the roof assemblies associated with the non-combustible types of type 1 and 2. So those provisions are already existing in the IBC. We're at poll question number 3, Lori. If you want to pull that up.
Sure thing. We got a true false here. Type 4 construction interior mass timber elements are permitted to be exposed without non-combustible protection with limited exceptions. And is it true or false? So you got a 50-50 shot of getting it right, even if you just guess. All right, and we're at 30 seconds, so I'll go ahead and close it. And
how do we do?
82% said true, so I hope that's the right answer. I'm pretty sure
that
it
is correct. remember, you have the type 4A, B, and C. Again, equivalent risk, equivalent performance. Type 4A is your tallest building number of stories and highest, in overall height at 270 and 18 stories. Type 4B steps down to 12 stories and 180 feet in height. And then you go down to 9 stories and 85 feet for a type 4C construction, but you still have to have that 2-hour fire resistance rating in type 4C and type 4B. So we started to hint at discussions for non-combustible protection of exterior walls. Again, we don't want our structure to be involved in a interior building fire that's going to negatively affect an adjoining property. We certainly don't want any other structure fire or building or property fire to negatively affect our building from the outside in. So in all types of the new types of construction, type 4A, B, and C, we mandate 1 layer of 5/8 type X gypsum or equivalent on the exterior of the building. The CLT can be unprotected around openings. Remember, we have some inherent fire resistance from the mass of the CLT itself. And we do have some minor exceptions for things like water-resistant barrier. The most important thing to remember, if you have to do exterior insulation in terms of the energy code to meet your energy code limits under the IECC, you won't be installing any combustible material. I think we all know the tragedy that occurred in the UK, in London, the Grenfell's Tower, where they had some exterior aluminum cladding system that was infilled with some, unfortunately, combustible insulation, and the heat and smoke was enough to break some of the glass on the units, and a lot of people were unfortunately asphyxiated because they used a combustible insulation product in the cladding system on the outside of the building to try to bump up their energy efficiency numbers. So unfortunately, 77 individuals lost their lives. We certainly don't want to repeat a mistake of that magnitude. We want to keep our building occupants safe. So we have some non-combustible requirements associated with the exterior components outside of the envelope, the CLT envelope. So when we look at type 4A, in this particular detail, we're showing a furring channel, non-combustible furring channel installation with a gap or an offset for running some appurtenances through there. But we have a total of 3 layers of 5/8 gypsum. And again, remembering we need 2/3 from the non-combustible protection. So 40 minutes, 80 minutes, 120 minutes are 3 layers. So that gets us to our 2 out of 3 hours. And then the structural mass of our CLT makes up the other hours. So let's say you're the design professional in charge and you're looking at quotes from the manufacturer. They say 5 panels will work with the structural loads, live loads, dead loads, wind loads, everything else. But you want to have some exposed CLT, or even if it's type 4A and you're that tall, you might have to beef up the section, the thickness of your CLT assemblies or beams, glulams, columns, whatever it is, to account for the additional required extra 1/3 or 1 hour fire resistance for these taller structures. You have to achieve that 1/3 fire resistance from the mass timber elements itself. There are some other more criteria associated with the furring channel, and there's some ASTM specs listed there for your reference as well. So we're looking at an exterior wall. This should look very, very uniform across all the types of construction, type 4A, B, and C. You're going to have 1 layer of 5/8 type X or equivalent exterior protection on the outside. It was on the slide previously, but you don't need any protection in the window openings. You just need it on the exterior wall covering. And then you need a total of 3 layers of 5/8 type X or equivalent on the inside of the building to ensure you meet the 3-hour fire resistance rating for type 4A. Just a little schematic there for you showing 18 stories. All mass timber elements must be wrapped with non-combustible protection both inside and outside. And floors also have to go through the additional extra step of having a 1-inch thick layer of non-combustible material on all the floor surfaces. Here's an example of a type 4B exterior wall. So we go from a total of 3 layers down to 2. Again, we still need 2/3 of the required fire resistance rating from the gypsum. So we need a total of 120 minutes. 2 layers of 5/8 type X gives us 80 minutes. We get the other 40 minutes from the inherent fire resistance of the mass timber elements in type 4B construction. Same requirements for exterior fire resistance. We need 1 layer of 5/8 type X on the outside of the building to protect it. So under type 4B, we're going to show you some illustrations of some typical or potential configurations of how to expose the aesthetic qualities of wood underneath those underlying layers of gypsum, non-combustible gypsum protection. So there's configurations to do exposed CLT members on the ceilings and the walls. So when we look at those exceptions, everything has to be protected except unprotection of portions of mass timber ceilings, including the attached beams, shall be permitted and shall be limited to an area equal to 20% of the floor area in any dwelling unit or fire area. Just want to clue you into the language there, in any dwelling unit or fire area. That's so the building official, the fire official can accurately determine what those areas are and then thus measure and determine if the 20% of that floor area was achieved. Same thing goes for the walls. You can have up to 40% of the floor area in any dwelling unit or fire area of the walls exposed, and you can even have them in configurations such as walls and ceilings exposed, provided you comply with the provisions under exception 3 in the following code sections. And if you go one step further here, they even went so far to say mass timber columns and beams which are not integral portions of walls or ceilings. In other words, not part of the primary structural frame, shall be permitted to be unprotected without restriction of either aggregate area or separation from another. So if the beam or columns is a faux beam, if it's heavy timber, mass timber elements, but it's not really an integral portion of the walls or ceilings, it does not need to be protected because it's not going to be a life safety issue or collapse issue if it's only if it's not integral to the walls or ceiling. So exception number 4 may be applied simultaneously along with the exceptions 1, 2, and 3. So there's the exposed ceiling in ATF test number 2. And we have some schematics of different configurations that you might see based upon, 20%, 30%, 40% exposed. So here we have 2 opposing walls very far apart, just about half protected. When we start looking at those unprotected areas, just like everything else, there's calculations to do. This calculation will tell you what your permitted total unprotected mass timber, ceiling, and wall areas are. You can use this calculation to determine that. And again, it's in accordance with dwelling areas and fire areas, so it can be verified in the field. So here's a potential configuration. We have an exposed wall assembly on the far right, and we have exposed ceiling assembly above the door. And we'll get into a little bit more detail with these, but they're typically mandated at 15 feet apart. So you can have exposed ceilings and walls, but they have to remain over 15 feet apart. So there's the code language there, separation of unprotected mass timber, 602.4.2.2.4. Dwelling unit or fire area, unprotected portions of mass timber walls and ceilings shall not be less than 15 feet from unprotected portions of other walls and ceilings measured horizontally from the ceiling and from unprotected portions of walls measured along the floor. And it's just hammering home that there has to be a 15-foot separation between the unprotected surfaces and type 4B construction. So type C, again, 85 feet overall height, maximum number of 9 stories, non-combustible protection is mandated in certain areas, but the rest of those areas not included can be left exposed. We still need 5/8 type X or equivalent on the exterior portion of the walls, and the floors have to be in accordance with section 808.804 in the IBC. Remember, you need non-combustible topping in buildings that are construction of type 4A and type 4B. You can have mass timber and concealed spaces, but they have to be protected, and you're allowed no other combustibles in plenums other than what's currently permitted in the code. And shafts and stairwells need to be protected both inside and out with a 40 minutes of non-combustible gypsum or equivalent. So that's just an example. We have fully exposed mass timber elements on the interior. Again, we still have to comply with a stringent 2-hour fire resistance criteria, but we still need to protect the exterior wall with 1 layer of 5/8. Poll question number 4.
Sorry, I was muted there and talking to myself. Okay, so
nope, happens all the time.
Which of the following construction types permit mass timber buildings up to 12 stories or 180 feet in height? So type 4A, 4B, 4C, or all of the above?
I'm rooting for you all. Come on, get this right.
But remember, if you do get it wrong, it doesn't have any impact on your CEUs, so it's okay. All right, we're at about 30 seconds, so let's go ahead and close it and share the results. So
how'd we do?
This one could be a little tricky. We had 21% who said type 4A, 52% who said type 4B, 8% said type 4C, and 19% said all of the above. So Matt, you want to discuss the answer on this one?
Sure. We had some folks just went for the default, all of the above, but in this case, we're talking about buildings up to 12 stories or 180 feet in height. Now, technically, you could have a type 4 building that had a 3-hour fire resistance rating that could be 12 stories or 180 feet maximum. But the key here is partially exposed mass timber, right? So we have fully exposed mass timber buildings for type 4C construction. We have code permitted options to allow us to expose ceilings, partially exposed ceilings and walls associated with type 4B construction. Type 4A would be just like the Brock Commons building, where you have 3 layers of gypsum over everything. You'd walk into the building, you wouldn't be able to tell if they're steel columns or wood columns because everything's buttoned up with non-combustible gypsum protection in type 4A. So sorry if we tricked anybody, but it's when we talk about it, partially exposed mass timber buildings, we're talking about the construction type of type 4B. So fire resistance. This is really one of the key tenets that we just want to make you aware of. The fire resistance ratings that are determined for non-combustible protection, and in most cases gypsum products, are taken by testing the unprotected element and then testing it with the protected element. So the CLT manufacturer is going to submit his or her products for testing. They're going to put the CLT panel in the furnace, do an E119 test, ASTM E119 test, burn the piece of CLT, and they're going to take the same, new uncharred piece of CLT, if you were, wrap it up with the required number layers of gypsum, and subtract the values and determine what the fire resistance rating is for that particular product. So in this case, in the detail we have shown here, we're showing what was probably a type 4A detail. So we have 3 layers of hopefully 5/8 type X gypsum wallboard. You can see we're lapping the corners, and we'll get into that a little bit more in detail. But we want to take the time attributable to the non-combustible gypsum and then add that layer of protection to delay the negative effects of fire and combustion that the CLT or mass timber would be subjected to if it wasn't protected by the gypsum. So the determination of non-combustible protection time is under section 703.8. You're going to get the fire resistance time of the non-combustible protection in minutes, and you're going to do test 1 without, and then test 2 is protected, and you subtract those values for time in minutes from those 2 tested assemblies. And in 703.8.2, the projection shall be fully defined in terms of configuration details, attachment details, joint sealing, accessories, and all other relevant details. And as we get further along in these modules, we have detailed provisions about sealing and everything else, but we're not going to quite cover that today. But it is very detailed on how CLT materials butt up against each other and other materials, how they're sealed, how the joints are protected, how the connections are protected, basically housekeeping, that sort of thing. So we know from our components that a sheet of 5/8 type X gypsum is good for 40 minutes. So we have configurations of 1, 2, or 3 layers. If we're going to use 1/2-inch gypsum, we have slightly less at 25 minutes. And if we're using 5/8 gypsum, we're back up to 40 minutes per layer. So gypsum, if we're using non-combustible protection as gypsum wallboard, we have to have very detailed provisions for the type of screws, the material, the construction, the threads, everything else, how the joints are lapped, what the fastener schedule is, what the penetration is. These are all very, very detailed aspects of the installation in terms of drywall screw. So when you get into the actual code change provisions, you'll see that type S screws are typically called out in the specifications. Type S or steel or self-drilling tapping screws are commonly associated with attaching gypsum to steel studs, versus a type W screw would typically be associated with driving a screw into a wood substrate. But they found out through testing that the type S screws tend to hold a little better. I believe the threads are a little bit finer. They seem to hold the gypsum to the CLT substrate a little bit better. But the very, very detailed fastener schedules, very, very detailed lapping requirements, abutting joints, edges, and we already talked about the lapping of the corners in the wall ceiling assemblies when we're doing this non-combustible gypsum protection. So we have a couple details that kind of depict that, but those are covered in 722.7.2. And you can see we have a pretty aggressive fastener schedule. The base layer has to go into the wood, wood substrate so far, and then each adjoining layer of gypsum wallboard has to be fastened progressively with a minimum depth of penetration into the previous layer. We have offsets and staggering and dimensions associated with distances to the panel edges and other joints, and then all that can be found in section 722.2. Here we are calling out the number 6 type S drywall screws and calling out the fastener patterns and indicating that the ceiling gets installed first, then the wall, then the ceiling, then the wall. Again, we're staggering or stair-stepping those gypsum joints at the ceiling. Exterior surfaces, we have provisions for securing the non-combustible gypsum or equivalent to the outside of the building. We're using exterior locations now, so we have to switch over to galvanizing, whether they're nails or screws, but it has to be secured properly in accordance with these new provisions under Chapter 7. So we're going to open it up for question and answer right now. I can go ahead and pull up one of the other videos. If we have any questions in the chat box right now, we can certainly go live with that. Looks like we have one more poll question at the end. Lori, if you want to launch that one.
Yeah, I'll go ahead and launch that. All right. Which of the following is not true for the fire resistance rating for exterior bearing walls? Type 4A must be 3 hours. Type 4B must be 2 hours. Type 4C must be an hour, or none of the above.
The suspense is killing me.
We are at about 30 seconds, but I'll give folks a little bit longer since this one's a little bit more challenging and try to get it closer to 70 or 80%. All right, great. Let's go ahead and close it. And this one was
Survey
this
says
one was a little bit answers were a little bit scattered. I think this was a hot topic. So do you want to go ahead and talk about the results? We had 16% that said choice A, 10% said choice B, 32% said choice C, and 42% said none of the above.
Okay, well, let's remember what do they say at West Point, right? Read the problem, and then the second part of the instructions is read the problem. Which of the following is not true regarding the fire resistance rating for exterior bearing walls? So we're not talking about the exterior covering. We're talking about the exterior bearing wall of the assembly itself, right? So we remember that both Type 4C and Type 4B have minimum 2-hour fire resistance ratings, right? So when we indicate that Type 4C must be 1 hour, that's the old traditional heavy timber. Some of the not exterior walls, but some of the provisions for Type 4 traditional heavy timber were assumed to be 1 hour. Not the case with the new Type 4B and Type 4C. Both of those are 2 hours, even though we're fully exposed. We're only at 9 stories and 85 feet, which, let's be honest, is tough to get 9 stories in. The existing overall height limit for traditional heavy timber Type 4 is the same 85-foot height limit as it is for Type 4C. We still need that 2-hour fire resistance rating for Type 4C. So our mass of our structural mass timber elements have to be robust enough of a certain size to account for decay and reduction in structural performance. And for fire safety and building and occupant safety, that needs to be 2 hours. So Type 4B and Type 4C are both 2 hours, and Type 4A is 3 hours. Sorry to add that. Sorry to end that on a bad note, folks. I apologize if there was any confusion about that. So as Lori indicated, we just wrapped up Module 3 here. We have Module 4 coming in November and Module 5 coming in December. If you're hopefully you're signed up for our education emails and you're getting these in your inbox. We just have a couple more resources available for you. If Lori, do you want me to go through education, or you want to take it?
You can go ahead and talk about the resources, and then we'll do Q&A.
Sure.
So folks, make sure you
Perfect.
Stay on until 3:30 to ensure that you've met your time in session. So.
We got about 10 minutes, so she have plenty of time to answer your questions. If you're camera shy, don't want to post it, please feel free to send us an email. We'd be happy to get back to you. So if you go to awc.org, you can see in the top bar there, the education tab. This presentation and many others are available for you to view. Sometimes some are YouTube videos, some are PDFs. If you partake in these videos, you can join several different ways. Become a member of AWC. Basically, you can sign up for education classes. When there's a webinar like this one, you'll get an email. We don't sell your email to anyone, and we'd be happy to bring you into the fold, so to speak, to get you up to speed with webinars and assist you with your continuing education needs. So we have in-person seminars, of course, prior to COVID-19, monthly webinars, recorded presentations, and different CEUs available. We realized that this one was AIA and ICC only. Lori, are you still working on NCSEA, or is that something that's forthcoming for some of these? Or
We should have it available. It's something that we may be looking to adjust in the future. But
Okay.
let's jump into some Q&A, since we seem to be having some good questions roll in here. And we can.
And I'll just leave up the cover page here for the Code Official Connections. That's a free program where you can get education and training. And we talked a little bit about construction fire safety. This is just something that's near and dear to my heart. I don't want to see any buildings burn, let alone a wood building. But safety is no accident. So if you have some questions about what's coming on the 2021 codes with construction fire safety, IBC set up this website, Construction Fire Safety, lots of great resources on there. And the best part is, for Code Official Connections, the education and construction fire safety, we're a cheap date. It's free. So we'd appreciate if you take a look at that, and we'd be happy to answer any questions you might have regarding this particular presentation.
All right, so the first question we had relates to, we actually had a few questions related to insulation. So the R value of wood is about 1.25 per inch. So a 5-ply panel, we figured out, you and I figured out earlier, has an R value of about 9.3. Where else would people provide insulation to be able to meet the energy code requirements on a mass timber
That's
building?
a great question. So there are mass in the upcoming energy codes. I believe there's a mass wall definition that mass timber can comply with. In some of the warmer climate zones, I think that because of the lack of a leaky envelope with a cross-laminated timber or mass timber building, you have your penetrations, ductwork and fenestration, but you don't have the repetitive light framing to have all the voids and gaps in. So they have to seal. There's joint sealing requirements for the mass timber elements. So it makes it a pretty airtight structure. So you're pretty far ahead of the game in the warmer climate zones. As you get into the colder climate zones, you're going to need to address that with some exterior insulation. As we discussed about the Grenfell's fire tragedy, there was no combustible materials permitted outside of the mass timber envelope, with the exception of the water-resistive barrier that's currently permitted under the code. So your non-combustible rigid board products, we're not going to mention any trade names, but your non-combustible rigid board assemblies in different depths could be secured directly to the outside skin through the drywall of the building, and then have your rain screen or your curtain wall assemblies go over top of that. But those insulation materials would have to be non-combustible. By non-combustible, I mean meet the NFPA criteria for not losing any mass during a fire test. Some insulation products are deemed non-combustible, but they will lose mass during a fire, and certain non-combustible woven insulation materials won't lose any mass during a fire, and they have to be non-combustible to comply with the intent of the code. So that's how you do it to secure the insulation on the exterior of the building.
All right, great. Some questions about MEP systems. We didn't really talk about this, but are MEP systems,
that's a good one.
Yeah, are they typically going to be surface mounted? Are they going to be flush? What are our options with CLT?
Yeah, so there was testing done for typical penetration. So don't be concerned as a designer. Don't be concerned about E84 penetration, ASTM penetration tests. There are rated assemblies and tested assemblies that permit penetrations of the mass timber elements. But just like in a heavy timber building, concealed spaces aren't really all that prevalent. So we envision a lot of visible ductwork, installed bundles, that sort of thing. It seems that every chain quick dining restaurant I go into now has ductwork hanging off the ceiling. So it's not unheard of, but the penetrations and some concealed spaces, there are some provisions there, but those concealed spaces and plenums have to be fully protected. You can't have chases or ductwork or plenum solely from the mass timber substrate. They have to be protected with non-combustible protection or gypsum or use non-combustible materials inside those plenums and ductwork chases.
Excellent. All right. Question on shear walls and diaphragms. So
not it. I'm going to pass. I'll keep shoveling coal. I'll let the engineer refer to this one.
I will be happy to provide some of my engineer insights on this question. But the question is related to designing CLT shear walls and CLT diaphragms, and where can designers find design values for these types of lateral force resisting systems. And so the short answer is currently there's not any standardized values. However, the 2021 special design provisions for wind and seismic is nearly completed and will be referenced in the 2021 IBC. In there will be allowable shear values for diaphragms and CLT shear walls, I believe. And so that will be a resource that will be available for engineers. Also, manufacturers will have some specific design value for their product that they probably have tested. So, if you're building a CLT structure, talk to your CLT supplier beforehand, and it can save you some headaches and redesign later.
Yeah, there was some. It's a shame. Keep fielding the questions, Lori. I'm going to see if I can pull up that. It's worth noting that shake table test from
sure, yeah,
that Simpson did in Japan with Avalsa. I don't know if I have that, but if I can, I'll gladly pull up the video. It's a great video that shows the world's largest shake table conducting some seismic testing on a 6-story.
Yeah, pretty impressive.
Pretty cool.
Test.
So go through the questions. I'll try to grab it real quick
and
if I
just
can.
to comment on the lateral force resisting system design a little bit more. For seismic design, one thing that you will need that we don't have currently for CLT shear walls is an R value, and that comes from the seismic chapter in ASCE 7. We are doing lots of testing as well as report writing on these tests that we've been doing. Matt referred to one shake table test. There have been multiple shake table and diaphragm and shear wall tests that have been done. So the information will be published hopefully in the next version of ASCE 7, which will be ASCE 722. And from there, it will hopefully roll into the IBC 2024, which will be the next update of the IBC. And that's just one of those things that happens when you're developing standards on different schedules, and you can't necessarily develop things exactly at the same rate or time. So unfortunately, there's a little bit of a disconnect between what's in our standard versus ASCE versus IBC, but they hopefully will get caught up in the next cycle once all the information has been published from all the tests.
So do you have any more questions? I was able to track it down on YouTube. So if anyone's interested, we'll gladly stay on board for the Q&A for a minute or two. Any more questions? Or you can just email us at info@awc.org. But in the meantime, I'll just drag this over here, Lori, if I have the screen.
Yeah, if you want to go ahead and show that real quickly, we can do that, and then I will get the.
Is my screen sharing? I'm
it
sorry.
Is sharing. Yes, you're good. So and while you're showing that, I will queue up our closing slides so we can close things out for folks.
This shake table test, I believe, was done at least a total of 10 times, and it was to simulate the Northridge earthquake. So you can see in the upper floors there how violent it is. They have an interior camera as well. But there's been
that one was actually
the
Kobe, Japan earthquake.
Oh, was it? I thought it was a Northridge. I'm sorry.
I'm sorry. I think it was 1996 Kobe. All right. So
if you were having coffee in this space, you'd be in for a rude awakening.
So it's quite dramatic, especially from that angle.